All right. Next, what I'd like you to do is take some time to look at these three graphs there, labeled graphs 1, 2, and 3. And I want you to figure out which two happen to be the same. Pause the video, take your time. When you think you've identified it, restart and see if you are correct. All right, so what graphs did you pick out? Did you happen to pick out graph number 1 and graph number 2 as being the same graph? Those graphs are actually the same, and if you look, and in each case here, for both of these, every vertex is connected to every other. So even though they don't look the same, they actually are the same graph. When you look at graph number 3, you'll notice that we have J and K being connected to each other twice, which is not the case in either of those two graphs. We also have I and L not being connected at all. That makes graph 3 different in terms of graph number 1 and graph number 2. Whenever you're finding equivalent graphs, one way to think about it is to imagine a graph drawn with computer software that lets you drag those vertices or edges without detaching them from their vertices. And if you can like drag stuff around and move it, and the edges stay there, they stay intact, then and create the graph you started with, then those are going to be equivalent graphs. Okay, so let's take a look at some of the graphs down here at the bottom and figure out if these graphs happen to be equivalent. So here in, we'll call this pair number 1 right here. Pair number 1, I think it's fairly easy to see that what has happened is we've taken the line that connects A and B in the first graph and wrapped it around kind of the long direction here from W to V in the second graph. So we've just repositioned that line, if you will. And so these graphs, yes, are equivalent. Okay, looking at the second pair, moving over to the right, these graphs, I can tell at a glance, now again, I practiced this a lot more than you, but I can tell at a glance that these are not equivalent, and here's why. This graph on the left, vertex A and F, those both have degree 1. However, if you look at the second graph there, there's only one vertex of degree 1. And so those are not going to be the same in terms of being equivalent graphs. All right, then moving down to our third pair here, which I'll call number 3. Are these going to be equivalent graphs? And again, I'm going to give you a second to look at those and see what you think. Pause the video. Determine if they're equivalent or not, and then come back and see if you have made the right decision. Okay, ideally you decided that yes, these are equivalent graphs. I kind of look at it from the perspective of like dragging and dropping those vertices. I kind of look at taking the second vertex and taking the square here that's kind of aligned in the front, and I think about moving these vertices kind of up and out in this direction so that it does kind of frame up that square or rectangle there in the middle, and that might help you see that those actually are indeed equivalent graphs. Okay, in this last example, we're going to take these 4 different graphs, and we're going to try to find out which, if any of them, happen to be equivalent. Now again, lots of strategies for doing this. If you want to Google ways to find out if graphs are equivalent, you Google it. You'll have all kinds of stuff pop up. But what I tend to do is I tend to find a vertex of like highest degree or potentially lowest degree, and I just try to match up things as we go. So in this first graph here, I notice that this vertex right here, which I'm going to call A, has degree 4. And so I'm going to label that. And the first thing I have to do is if these have any chance of being equivalent, each of these graphs has to have a vertex somewhere of degree 4. And so the second graph does right here. So I'm also going to label that vertex A with degree 4. The third one has a vertex of degree 4. And so does this last graph there have a vertex with degree 4. And then I'm going to branch out from there. So going back to the first graph, then I notice kind of moving up and to the left, this next vertex, which I'm going to label B, has degree 2. So looking at each of the other graphs, I have to see, starting at the vertex labeled A, is there a vertex adjacent to it that has degree 2? In the second graph, yes, there is. It's that one right above the one labeled A. In my third graph, if I move over to the right, that one has degree 2. And in my last graph, if I move to the left, that that vertex also has degree 2. So right now, so far, what I have labeled, those look like we've got contention to be equivalent in every case. Now, starting at that vertex, which I've labeled B2, back in my first graph, I notice it is connected to another vertex of degree 2, which I'm going to label C2. So I just keep track of the degree. When I look at my second graph, B2 isn't connected to anything of degree 2. I can wrap around here to this vertex, but that's not degree 2. So that one's definitely not going to be equivalent to the first graph. When I look at B2 in the second graph, the only thing it's adjacent to that hasn't been labeled is over here. That also has degree 3. So we're not equivalent to that second graph, or the third graph, excuse me. And then looking here to this last one, B2, again, moving that direction because A is already labeled, that's got degree 3 as well. So in no case do I have a degree 2 labeled B that I can connect to a degree 2 that I could potentially label C in any of those other cases. So this first graph is not equivalent to any of the other three. So what I'm going to do now is I'm going to focus on this second graph, the one I have labeled B2, and if I wrap that edge around to the next thing that's not labeled, I can label that next vertex. I'm not going to use C, I'm actually going to use D since we've already used a C and it didn't work out. I'm going to label that D3. Okay, it's a vertex with degree 3. From my vertex labeled B in my third graph over here, graph number 3, I can go this direction and I find that there is a vertex here with degree 3. So that's a D3. And then in my graph here, graph number 4, if I follow that same edge that I've already got an arrow on, that has degree 3. And so that can be a D3 as well. Okay, then what I'm going to do is go back here to my second graph, number 2, and I'm going to start from D3 and I'm going to see where it leads me. So A4 is already labeled, can't go up, can't go to the left, that's already labeled. So I'm going to go here. That's going to be E with degree 2. Going to graph 3, from my vertex D, I can go to E, which is degree 2. And then in my last graph, number 4, I can go from D to a vertex E, which has degree 2. So far, I've got all three still in the running. I'm going to go back to graph number 2 again. From vertex E, I can travel up that curved line. I'm going to call this vertex F. It has degree 3. From vertex E2 in my graph 3, I can travel across to vertex F, which has degree 3. And in my last graph, number 4, I can travel from E up to this vertex, which also has degree 3. So again, so far, all three graphs look like they could be equivalent. Going back to graph 2 again, from F3, I can travel down to this next vertex. I'm going to call that G2, which notice connects to my vertex A. Okay, so from F, I have to go to a degree 2, and it's got to connect up back to my vertex of degree 4. Moving on to graph 3, I'm at vertex F. If I move to either vertex, actually, I'm going to go up here to this one. I could label that G2, and I notice that it does connect back to my vertex of degree 4. So again, those two still look like they could be equivalent. And when I move to my graph number 4 here, from F, I can go down and to the right just a little bit. That has degree 3. I can go down and further down and to the right to that vertex. It also has degree 3. I cannot label these. There's no degree 2. Okay, neither one of these vertex are of degree 2. And so that graph right there must be out of the picture. So then the last thing I need to do is make sure that this final vertex that we haven't had any labels on, let's make sure they're actually equivalent. So I can go back and I notice that this first vertex here, the one I'm kind of circling again, it is linking up, it is adjacent to A and to F. Okay, it has degree 2. And in graph number 3, this vertex that I'm circling a lot, again, it links to A and it links to F. And so it's these two graphs here in the middle that are equivalent.